All right. So today we're going to be starting a series where we're going to be reading Shape Up, which is my favorite approach for product development. And as a bit of a primer before we get into reading here, I just wanted to cover kind of my history with product development process and studying different approaches. So I've studied lean manufacturing in particular for over a decade now. And I really strongly feel that there's a lot to gain from studying other industries and applying lateral thinking. So looking outside of software development specifically. And after, studying lean manufacturing in particular, I feel like a lot of software development approaches really miss the point of lean entirely. Now, outside of this independent study, I've worked with teams that had every kind of process. So some teams had no process at all, which was definitely not ideal. And others did variations of Agile or Kanban with, strict Scrum or loose interpretations of Scrum, which is probably the most popular approach, is kind of the imagined approach of Scrum without really adhering to the original intent. Um, and in my experience of all these different approaches, ShapeUp has really proved to be the most successful product development process. Uh, and the reasons for that is it reduces overhead and waste. It preserves quality as the main thing to protect. And it really creates a calmer way of working. Whereas a lot of times with Agile and Scrum approaches, you feel like you're always sprinting, you're always in the middle of a marathon, you're always in a crunch mode, and there's never time to stop and reflect or as an individual contributor to really get to the things that you need to do to address tech debt or think more critically about process and the product itself. So I've implemented ShapeUp with 4 teams now of various sizes, and I have a lot of thoughts and advice as well as adaptations from what we'll see in the book. Um, and what we're basically going to be doing is we're going to be reading through the online book for ShapeUp, and as we go, I'll share my thoughts, my experience, my advice. And at any point, feel free to ask any questions you might have, and I'll be sharing resources along the way as well. So, with that out of the way, let's dig right in. So, kicking off, we have ShapeUp. This book is a guide to how we do product development at Basecamp. It's also a toolbox full of techniques that you can apply in your own way to your own process. Whether you're a founder, CTO, product manager, designer, or developer, you're probably here because of some common challenges that all software companies have to face. Growing pains. As software teams start to grow, some common struggles appear. Team members feel like projects go on and on with no end in sight. Product managers can't find time to think strategically about the product. Founders ask themselves, why can't we get features out the door like we used to in the early days? These pain points are definitely relatable to me in my experience. That feeling of sprinting, it feels like projects are unending. And a big part of that, as we'll explore, is that even if there are set deadlines, there's other mistakes along the way that cause those deadlines to basically slip indefinitely. Also, when you're sprinting, as I mentioned, you never really get that time to reflect on what to do next or to really take a step back and think more strategically about next steps. And as a result of always sprinting, of never taking time to reflect, you often see that your velocity will slip along with quality. So you'll have growing tech debt and a huge backlog, and you never really get through the roadmap that you put ahead of yourself. We saw these challenges firsthand at Basecamp as we grew from 4 people to over 50. Basecamp started off in 2003 as a tool we built for ourselves. At the time, we were a consultancy designing websites for clients. Information would get lost in the game of telephone between the client, the designer, and the person managing the project. We wanted Basecamp to be a centralized place where all parties could see the work, discuss it, and know what to do next. It turned out lots of companies had this information slipping through the cracks problem. Today, millions of people across all kinds of industries rely on Basecamp as their shared source of truth. So just a quick caveat, this book was written by Ryan Singer when he was overseeing product at Basecamp, and since then he's moved on. So the book is really Basecamp, emphasized in a lot of ways, but the approaches, especially after Ryan Singer moved on from Basecamp, have been shown to be more applicable more broadly as well. 3 of us built the first version. Jason Fried, Basecamp's founder, led the design. His co-founder, David Heinemeier Hansen, programmed it and created the well-known framework Ruby on Rails as a byproduct. At the time, I was a web designer with a focus on usability and user interfaces. I executed Jason's design direction for key features of the app and collaborated with him to fill in details of the concept. So there's something interesting about these initial trio of people that built Basecamp, and this is something that will be echoed throughout ShapeUp, basically. They had design, engineering, and product perspectives all working together. So that's one of the reasons that they may have been successful in their first approach to building Basecamp. From the first prototypes in July 2003 to launch in February 2004, David only worked 10 hours a week. We knew we couldn't get anywhere with those 10 hours of programming unless we used them very deliberately. Our intense focus on hammering the scope to fit within a given time budget was born under these constraints. This last sentence here is going to be key to all of ShapeUp, and that's this idea of giving a time budget and making the scope fit that budget. So we'll get into that pretty deeply. As the business grew, I started widening my skills. Working with David and Ruby on Rails made the world of programming accessible to me. I learned the techniques programmers use to tame complexity, things like factoring, levels of abstraction, and separation of concerns. With one foot in the design world and one foot in the programming world, I wondered if we could apply these software development principles to the way we designed and managed the product. So this straddling of both design and programming is kind of an early call to the established field of design engineering that's emerged in the last year or two. I myself am a design engineer, so I can really relate to basically having a foot in each side of things. And I also wanted to note that, taking a look at software development principles and applying it to product is an example of lateral thinking. That's something I already mentioned. For me, I found really effective lateral thinking by studying lean manufacturing, where you have physical factories making physical products and dealing with inventory and all of these things that make the process really visible and also make the waste very visible. So by learning from a physical manufacturing industry, it's a lot easier to apply those principles to software engineering. The first test of this idea came in 2009. By then, we had hired a few more programmers and offered 4 separate software as a service products. We managed to bundle the products together into a seamless suite with single sign-on and unified billing. It was a massive technical undertaking with treacherous user-facing flows. Besides getting the underlying architecture right, we had to interrupt customers on their way into the product and make them change their username and password for reasons that weren't easy to explain. I wore the designer and product manager hats on the project and prototyped the breadboarding and scope mapping techniques described in this book to manage the complexity. And this idea of contributing multiple perspectives through one person is another thing we'll see. You don't always have to have each perspective filled by a unique person. You can have one person basically playing multiple roles in successful product development teams. We had such good results that we decided to apply the same techniques in 2012 when we redesigned Basecamp from scratch for version 2.0. Again, there was a lot of surface area to manage, and again, the process was surprisingly smooth. By 2015, we had a core team that had lived through these experiences and hit an impressive stride, but we found it hard to articulate what we were doing to new hires. Our product team had quadrupled and everyone worked remotely. That made it hard to pass on our intuitions. We needed language to describe what we were doing and more structure to keep doing it at our new scale. This language is something that Ryan Singer refers to as a pattern language, which comes from an architect named Christopher Alexander. So you'll basically find that throughout this book, he's establishing patterns of behavior that people can take on. So that's why things are a little bit more loosely defined and not quite as rigid as something like strict Scrum methodologies and things. To manage this new capacity, we switched from ad hoc product lengths to repeating cycles. It took some experimentation to find the right cycle length, 6 weeks. More on that later. We formalized our pitching and betting processes. My role shifted again from design and product management to product strategy. I needed new language, like the word shaping, to describe the upfront design work we did to set boundaries and reduce risks on projects before we committed them to teams. This switch from ad hoc project lengths to repeating cycles is basically a critical part of ShapeUp. They moved from flexible deadline with a fixed scope to a fixed deadline with variable scope. And this is one of the key takeaways. You could basically just implement this part of ShapeUp and get a lot of the value out of it. So what you do is you basically say, how much is this project worth to us and in terms of time? And that fixes a deadline in the future. And with that fixed deadline, we're going to do as much as we can to achieve it and preserve quality along the way, but we'll make the scope flexible. So if we're running low on time, we're just going to do less, but we'll still do it just as well. So this is like really the crux of ShapeUp right here. Just as we were getting better at articulating the way we work to ourselves, more and more of our friends and peers started coming to us to ask how we do it. Finally, Jason pulled me aside one day and said, I think you should write a book about this. This is the result. You can think of this as 2 books in one. First, it's a book of basic truths. I want it to give you better language to describe and deal with the risks, uncertainties, and challenges that come up whenever you do product development. Second, the book outlines the specific processes we're using to make meaningful progress on our products at our current scale. Here's a short overview of the main ideas of the book. 6-week cycles. First, we work in 6-week cycles. 6 weeks is long enough to build something meaningful start to finish, and short enough that everyone can feel the deadline looming from the start, so they use the time wisely. The majority of our new features are built and released in one 6-week cycle. Through experimentation, they found 6 weeks was comfortable, and in my experience too, I've worked with variable cycle lengths. I've worked in more of an R&D mode with certain teams that are at a startup stage, and it's funny because 6 weeks really does feel like the right cadence for things. I'm working on a large-scale personal project as well with a collaborator, and we're using 6 weeks, and it's funny that, you know, the work expands to fill the time, but it seems like really any meaningful chunk, 6 weeks is long enough that, you know, we get a lot done, but you don't get demotivated from just never shipping anything. Our decisions are based on moving the product forward in the next 6 weeks, not micromanaging time. We don't count hours or question how individual days are spent. We don't have daily meetings. We don't rethink our roadmap every 2 weeks. Our focus is at a high level. This is key. This is one of the biggest savings with ShapeUp is the reduction of overhead and waste. So they don't do any estimations. They don't have daily stand-ups or weekly retrospectives or backlog grooming sessions or kickoffs or any of these things that really eat up our calendars and are really distracting with context switching. And also day to day, there's no like stand-ups or we're basically supervising the work being done as long as they see that overall progress is being made. So that alone alleviates a lot of the time spent, and it allows even more of basically contributor time to be in deep work, which just accelerates the work in general. There's also this aspect of a roadmap, and what we'll find in this approach is that there is no roadmap. So instead of after every sprint, you look at the roadmap and have to make re-estimations and resequence everything, there is no roadmap at all. And that's actually going to be a key advantage that we'll dig into in a bit here. We'll say to ourselves, if this project ships after 6 weeks, we'll be really happy. We'll feel our time was well spent. Then we commit the next 6 weeks and leave the time, then we commit the 6 weeks and leave the team alone to get it done. Shaping the work. Second, we shape the work before giving it to a team. A small senior group works in parallel to the cycle teams. So this small shaping group working adjacent to the cycle teams or the implementers, this is something that happens more at scale with ShapeUp, but it's kind of rare in my experience. You would have to have a pretty defined team and more of a mature practice with it, maybe a larger company. So a more approachable adoption of ShapeUp means that product design and engineering, who often are also the people building the work, are all represented with the shaping work, the framing work that we'll get into. And a lot of this work will happen during between cycles, basically, instead of in parallel to cycles. So that's kind of a key distinction of how to adopt this more feasibly within your team. They define key elements of a solution before we consider a project ready to bet on. Projects are defined at the right level of abstraction, concrete enough that teams know what to do, yet abstract enough that they have room to work out the interesting details themselves. When shaping, we focus less on estimates and more on our appetite. Instead of asking how much time it will take to do some work, we ask how much time do we want to spend? How much is this idea worth? This is the task of shaping, narrowing down the problem and designing the outcome of a solution that fits within the constraints of our appetite. Again, this is the core piece of ShapeUp right here. We aren't going to have deadline slip because we first have chosen an appropriate appetite or time budget, basically. And by fixing that point in the future, we're also going to shape the work or basically scope the work appropriately. And as we build out the product or the project for this cycle, we're also going to keep adapting the scope to make sure we ship on time no matter what. Making teams responsible. Third, we give full responsibility to a small integrated team of designers and programmers. They define their own tasks, make adjustments to the scope, and work together to build vertical slices of the product one at a time. This is completely different from other methodologies where managers chop up the work and programmers act like ticket takers. I can definitely relate to this, especially with Scrum, where it seems like the user stories, for example, have already been defined by a stakeholder, and they're basically handed down. And you get a slew of tasks, and you're asked how much time will each of these tasks take, and then that's measured against the capacity of the cycle based on historical velocities and all these things. And inevitably, all the estimations are completely inaccurate, and there's no agency or latitude from the team building the work to question whether each task is required or to even inform the approach of the tasks themselves. And instead, with ShapeUp, you are given basically a clear vision of where to go, but it's up to you to discover and define the work that needs to happen to get there as efficiently as possible. So this eliminates a whole other source of overhead and waste and basically just motion that happens in other product development processes. Together, these concepts form a virtuous cycle. When teams are more autonomous, senior people can spend less time managing them. With less time spent on management, senior people can shape up better projects. When projects are better shaped, teams have clear boundaries and so can work more autonomously. This is related to Jim Collins. He has a book called From Good to Great that talks about the concept of flywheels. And so this just kind of reminds me of that same idea where if you have time savings in one area, it's going to roll forward. And if you gain efficiencies in certain operations, that's going to start having compounding effects and make everything easier downstream, basically. Targeting risk. At every step of the process, we target a specific risk, the risk of not shipping on time. This book isn't about the risk of building the wrong thing. Other books can help you with that. We recommend competing against luck. Improving your discovery process should come after regaining your ability to ship. You can have the best strategy in the world, but if you can't act on it, what good does it do? Something I want to call out that is an evolution or a refinement of ShapeUp after this book was published is identifying this discovery phase as something that Ryan Singer calls framing. So I'll be referring to this prerequisite step of the process as framing as we go through this book. This book is about the risk of getting stuck, the risk of getting bogged down with last quarter's work, wasting time on unexpected problems, and not being free to do what you want to do tomorrow. We reduce risk in the shaping process by solving open questions before we commit the project to a time box. We don't give a project to a team that still has rabbit holes or tangled interdependencies. This is also part of that overhead of in a Scrum process where you have a lot of user stories and things. A lot of times those are pretty vague and there's a lot of assumptions about the solution being made and you're just handed those as an individual contributor. So it's really important. The focus of this book will be on how you define projects at the right level of abstraction, not overly prescribing those solutions, and making sure that people who are building it know what to do, but they are the ones in charge of figuring out how to get there, basically. We reduce risk in the planning process by capping our bets to 6 weeks. If a project runs over, by default, it doesn't get an extension. This circuit breaker ensures that we don't invest multiples of the original appetite on a concept that needs rethinking first. So this is a huge gain for teams that feel like deadlines just slip indefinitely. By placing one bet at a time, by saying we're only going to spend 6 weeks on it, that is the most, that basically puts like a maximum on the potential downside of a project. So things can't just spin endlessly on it. And then what's nice is after each 6 week cycle, you're completely clear in terms of if you have a clean plate, you can make a completely entirely different bet. You're not locked into a long-term roadmap that really limits your optionality. And lastly, we reduce risk in the building process by integrating design and programming early. Instead of building lots of disconnected parts and hoping they'll fit together in the 11th hour, we build one meaningful piece of work end to end, early on, and then repeat. This practice right here comes from lean manufacturing, and it's called one-piece flow. And there's a big misconception or almost myth with all kinds of companies where they think that the most efficient way to work is to do multiple things at once, to try and parallelize the work or to batch process things, basically. So they think if we have to get 5 things done, can we do them all 5 in tandem? And that actually leads to a much slower process because you have a lot of waste in that approach. You have the communication overhead, you have coordination overhead, you have context switching, which is really disruptive to people working on projects. And at the end of the day, you might make 20% progress on 5 things, but none of them are shippable. None of them really provide any value to the user. So instead, you really have to hone in on getting one thing done at a time. And with one-piece flow, you'll find that not only are you able to preserve quality, but you've reduced that inventory down. So you're actually going to work much more quickly as well. The team sequences the work from the most unknown to the least worrisome pieces and learns what works and what doesn't by integrating as soon as possible. So as they get this one-piece flow approach down and they're building one thing at a time, you're also solving those biggest risks up front, and you're also integrating them or basically shipping them iteratively as quickly as possible. So the focus is on delivering value as effectively as you can. How this book is organized. Part 1 is all about shaping, the pre-work we do on projects before we consider them ready to schedule. Each chapter explains a specific step of the process, from setting the appetite on a raw idea, to sketching out a solution, to writing a pitch that represents the potential project. Along the way, you'll learn specific techniques like breadboarding and fat marker sketching to keep the design at the right level of abstraction. Part 2 is about betting, how we choose among the pitched projects and decide what to do 6 weeks at a time. Part 3 is about building, the expectations we place on the teams, and the special practices they use to discover what to do. We'll look at how teams figure out what to do, how they integrate design and programming, how they track what's known versus unknown, and finally how they make the hard calls to finish the project on time. Lastly, the appendix gives you some help for when it's time to make changes at your company. There's some advice on how to try your first 6-week experiment, tips on adjusting the methods to your company's size, and specific guidance for how to implement ShapeUp using Basecamp. All right, so let's dig into principles of shaping here. When we shape the work, we need to do it at the right level of abstraction, not too vague and not too concrete. Product managers often err on one of these two extremes. Wireframes are too concrete. When design leaders go straight to wireframes or high-fidelity mockups, they define too much detail too early. This leaves designers no room for creativity. Our friend put it this way: I'll give a wireframe to my designer, and then I'll say to her, I know you're looking at this, but that's not what I want you to design. I want you to rethink it. It's hard to do that when you're giving them this concrete thing. Another risk of high-fidelity mockups is it's almost entirely waste. So if you're not building the thing and designing for the thing in context, in the final medium that your customers will use it in. Let's say if you build a web app, that means like it has to be in the browser. If you're not both programming, designing, evaluating things, creating the content, everything in the final medium, then everything you produce outside of that medium is a temporary artifact and is almost entirely waste. A good illustration of this is, let's say you did high fidelity mockups of every possible screen of your web app at every possible breakpoint, and each component was meticulously designed in Figma or another UI design tool, and it had every interactive state and everything detailed. Well, if you could have communicated that verbally and you could have looked at things in context in the browser, then almost all of that effort in the design tool is just waste. So by focusing on not defining work up front with too much detail, we're going to eliminate a lot of that waste. Because what we'll see is that all disciplines are going to build the thing together once the project actually kicks off. So there's no pre-design, there's no mock-ups being handed over as work or being thrown over the fence as it often feels like to programmers, for example. And that'll cut down on a lot of the waste because a lot of it can be communicated in much lighter ways. This also means that there's not going to be a distinct handoff phase. And this is a key thing that's really interesting to me is that Agile, is often posed as the antithesis of waterfall. And if you really do follow Agile, then that would be true. But most companies' interpretations of Agile or Scrum locks them in even more strongly into waterfalls, where they will have a design sprint that is followed up by a building sprint, which couldn't be any more of a waterfall sequence. So by basically saying, hey, we're not going to do any of this upfront design, especially high fidelity design, we have prevented that waterfall from occurring, and we've eliminated the waste of those temporary artifacts being treated as the most important thing to hang on to. All right. Overspecifying the design also leads to estimation errors. Counterintuitive as it may seem, the more specific the work is, the harder it can be to estimate. That's because making the interface just so can require solving hidden complexities and implementation details that weren't visible in the mockup. When the scope isn't variable, the team can't reconsider a design decision that is turning out to cost more than it's worth. So my note here is that fixed scope demands flexible deadlines by committing resources to work that you're not allowed to question. So if you're going to do upfront design with high fidelity mockups, you better be ready to just say it'll take as long as it takes, because that fixed deadline dream is basically gone. You've already locked everyone into a commitment that they have to build exactly what they see. And fixed scope harms quality by assuming solutions before defining what's essential or discovering all the opportunities. So even if you have invested a lot into high fidelity designs before you start building, you're often going to miss out on what's possible in the final medium. And you may have designed things that are going to burn a lot of your effort there. Now, if you want to say, okay, we have both fixed scope and we also want a fixed deadline, then the only thing that can give is quality, which means we're going to rush the work. It'll probably look nothing like the designs in the first place, and we're going to incur a lot more tech debt downstream from here. So this is where, basically upfront design already assumes a fixed scope to make it happen. So that's a huge risk factor. Words are too abstract. I have a note on this that I ran into this recently on a personal project where I was putting together what's now called a package. In this book, it'll be called a pitch that we'll get into. And I didn't include my rough hand sketches, so it was just a bunch of text. And it really wasn't clear alone with words what we needed to build the UI or what the feature was doing exactly. So this defining the project to the right level with words not being enough, that's definitely relatable for me. So on the other end of the spectrum, projects that are too vague don't work either. When a project is defined in a few words, nobody knows what it means. Build a calendar view or add group notifications sounds sensible, but what exactly do they entail? Team members often don't have enough information to make trade-offs. They don't know what to include or leave out. As a programmer who worked in that situation said, "You're solving a problem with no context. You have to be a mind reader. It's like we'll know it when we see it." Concerning estimation, underspecified projects naturally grow out of control because there's no boundary to define what's out of scope. And this is basically the same conclusion as overspecified projects. So if you under or overspecify, that timeline is probably going to slip because of either locking you into things that you're committed to building and you don't know how long it'll take, or if you don't know what you're building, then it's really hard to say when you're done. Case study, the dot grid calendar. Let's look at an example of how to shape a project to the right level of detail. We launched version 3 of Basecamp without a calendar feature. It just had a schedule feature that listed events one after the other without any kind of monthly, weekly, or daily grid. Soon after launch, customers started asking us to add a calendar to Basecamp. We had built calendars before and we knew how complex they are. it can easily take 6 months or more to build a proper calendar. These are the kinds of things that make a calendar complicated. Dragging and dropping events between cells to move them, wrapping multi-day events around the edge of a screen, different views for monthly, weekly, or daily timescales, dragging the edges of an event to change its duration, color-coding events for different categories, handling different expectations for desktop versus mobile interactions. I can definitely relate to this. I used to work at an agency called Dockyard, and I was working with Netflix as our client on some apps that we built for their Netflix Originals production. And it was a scheduling tool that had a calendar. And that was some of the most intricate UI state interactions, accessibility challenges I've ever encountered. So if you can avoid building a calendar, I highly recommend that. Past versions of Basecamp had calendars, and only about 10% of customers used them. That's why we didn't have the appetite for spending 6 months on a calendar. On the other hand, if we could do something to satisfy those customers who were writing us in one 6-week cycle, we were open to doing that. So this is where setting appetite is, and the framing or discovery stage as well, is really about the business strategy and the product strategy side of things. So you have to really carefully consider, is there an actual need for this to be introduced to the product? And is now the right time for it? Is this strategically the most important bet that we could place? So in their case, their previous version with the calendar didn't have much usage. They have some people requesting that, but they really want to unpack that language to understand what is the right solution that'll deliver the most value without, assuming this really large fixed scope. With only 6 weeks to work with, we can only build about a tenth of what people think when they say calendar. The question became, which tenth? I made a note here that this reminds me of essentialism, and there's this focus on simplicity that can really unlock solutions that are more elegant and more valuable than if you don't have any time constraint at all. So a lot of the best designs come with constraints, and a lot of the best solutions are also highly constrained. So it's probably a good thing actually to force yourself into this 6-week cycle with that circuit breaker of if we don't ship on time, there's no guarantee that we're actually going to finish this project or bet on it again. So you have to really focus on what's essential there. We did some research discussed in the next chapter and narrowed down a use case that we wanted to solve. We eventually arrived at a promising concept inspired by calendars on phones. We could build a 2-month read-only grid view. Any day with an event would have a dot for each event. A list of events would appear below the calendar, and clicking a day with a dot would scroll the events for that day into view. We called it the dot grid. The dot grid wasn't a full-featured calendar. We weren't going to allow dragging events between days. We weren't going to span multi-day events across the grid. We'd just repeat the dots. There'd be no color coding or categories for events. We were comfortable with all of these trade-offs because of our understanding of the use case. All of these things listed here is what we'll see in a future chapter. These are all the rabbit holes or the no-goes. These are things we're explicitly not going to do. And defining these is just as, if not more important, to get really clear on as what you are going to do, basically. Looks like there's a broken image here, so I can open up the original for this chapter. Sorry for blinding everyone with the light scheme here. So this is literally the level of definition for their projects. And this will be called a fat marker sketch in a subsequent chapter here. But you can see that the solution here that's handed over to programmers and designers to kick off together from the start is just enough to understand what the user interface should do and what it should look like without prescribing all the high fidelity details that will lock them into a fixed scope, basically. So let's go back to dark mode so I stop blinding everyone. Next up, note how rough the sketch is and how many details are left out. The designer had a lot of room to interpret how this should look and feel. At the same time, note how specific the idea is. It's very clear about how it works, what needs to be built, what's in and what's out. At the end of the project, the finished work that the designers and programmers created looked like this. So, sorry, I have to jump back to this actually. So you can see if they had prescribed this up front, that may have fixed the scope more than they wanted to. It may have overly constrained things. Maybe, what data to include here is all sorts of trade-offs. What would be easy and difficult to query from a database, etc. So this is the level of latitude that they give, or agency that they give to their individual contributors, basically. This small example highlights a few properties of shaped work. Property 1, it's rough. Work in the shaping stage is rough. Everyone can tell by looking at it that it's unfinished. They can see the open spaces where their contributions will go. Work that's too fine, too early commits everyone to the wrong details. Designers and programmers need room to apply their own judgment and expertise when they roll up their sleeves and discover all of the real trade-offs that emerge. We'll see too that the best design is because you made trade-offs. So that'll be a key point. And you want to allow the experts to make those trade-off decisions. Property 2, it's solved. Despite being rough and unfinished, shaped work has been thought through. All the main elements of the solution are there at a macro level, and they connect together. The work isn't specified down to individual tasks, but the overall solution is spelled out. While surprises might still happen and icebergs could still emerge, there is clear distinction showing what to do. Any open questions or rabbit holes we could see up front have been removed to reduce the project's risk. So the shaping stage is all about de-risking things, basically. Property 3, it's bounded. Lastly, shaped work indicates what not to do. It tells the team where to stop. There's a specific appetite, the amount of time the team is allowed to spend on the project. Completing the project within that fixed amount of time requires limiting the scope, or making it flexible basically, and leaving specific things out. Taken together, the roughness leaves room for the team to resolve all the details, while the solution and boundaries act like guardrails. They reduce risk and channel the team's efforts, making sure they don't build too much, wander around, or get stuck. And again, this is the benefit of that right level of abstraction. Who shapes? Shaping is creative and integrative. It requires combining interface ideas with technical possibilities with business priorities. To do that, you'll need to either embody these skills as a generalist or collaborate with one or two other people. So in future conversations about this, Ryan Singer has actually refined this a little bit to basically mean you have to involve product, engineering, and design perspectives all together. But those can be represented by any combination of people. So again, it could be one person, it could be 3 distinct people, it could be multiple people per perspective, but all of those people have to be represented. I'm going to share a link. This is Ryan Singer's talk at Y Oslo from last year, I think. So he goes into more detail there, as well as Shape Up in general. Shaping is primarily design work. The shaped concept is an interaction design viewed from the user's perspective. It defines what the feature does, how it works, and where it fits into existing flows. And this reaffirms a perspective that I've always had as somebody who does both design and development, that kind of everything is design in a product team. The content, the visual design, obviously, but also the programming side of it informs the design, the product strategy, all of those things inform the form and function of the final product. So it's good that all these perspectives are being honored as design roles, basically. You don't need to be a programmer to shape, but you need to be technically literate. You should be able to judge what's possible, what's easy, and what's hard. Knowledge about how the system works will help you see opportunities or obstacles for implementing your idea. This right here is a big risk of why upfront design often doesn't work out. And that's because it's very hard to find designers who can perfectly predict every detail of the engineering phase or the programming phase. Now, unless you're somebody who's literally doing both the visual design and the programming, you're going to miss out on both the limitations of the final medium as well as a lot of the opportunities. So you may not know what's possible. And even if you did know perfectly everything that happens in the next stage, if you're going to do upfront design, you would have to specify every last detail in advance and keep inventory of all that. And again, even if you achieve all that and you hand it off and it's a perfect requirement doc or a perfect high fidelity mockup, everything you just built, this perfect simulation of what you're going to build in the browser, is basically going to be deleted or forgotten about or ignored as soon as the project's done. So all of that effort and prediction and duplicitous kind of inventory, it's basically a form of pure waste as well. So instead of that, we should anticipate those needs and opportunities, but we shouldn't do all that upfront design. All right, so this is also strategic work. Setting the appetite and coming up with a solution requires you to be critical about the problem. What are we trying to solve? Why does it matter? What counts as success? Which customers are affected? What is the cost of doing this instead of doing something else? This is an important conclusion. When you shape, you're having to justify that this is worth doing, and you're having to justify that this is worth doing in contrast to other opportunities. You're only going to place one bet at a time, and this is the real meaning of priority. You can only have one priority. You should ideally only be doing one piece at a time. So you want to be really justifying that this thing is the singular thing that's most important to achieve next. Shaping is a closed-door creative process. You might be alone sketching on paper or in front of a whiteboard with a close collaborator. There'll be rough diagrams in front of you that nobody outside the room would be able to interpret. When working with a collaborator, you move fast, speak frankly, and jump from one promising position to another. It's that kind of private, rough, early work. 2 tracks. You can't really schedule shaping work because, by its very nature, unshaped work is risky and unknown. For that reason, we have 2 separate tracks, one for shaping, one for building. Again, this is something I touched on earlier. These separate tracks is a little bit more achievable at a larger scale, or if you're have a lot of maturity with ShapeUp. Not many teams are going to be able to pull this off. So instead of thinking of it as 2 separate tracks, think of it as 2 separate modes that you'll be in. So during the cycle, when your head's down building the thing, it's okay if you make note of potential next things to work on, and you might maintain some private, notes of what you might want to pitch for the next cycle. But a lot of the framing and shaping and bedding work that we're going to get into here is best to do during the actual cool down that happens between cycles, because it's pretty rare that you'll actually have these dedicated tracks basically within your organization. During any 6-week cycle, the teams are building work that's previously been shaped, and the shapers are working on what the teams might potentially build in a future cycle. Work on the shaping track is kept private and not shared with a wider team until the commitment has been made to bet on it. That gives the shapers the option to put work in progress on the shelf or drop it when it's not working out. This 2-track approach is really appealing because it removes that time dependency from shaping. So you could just have stuff incubating for months, and only when it's ready are you going to bring it to the bedding table. If you can't do this separate shaping track, then you just have to have a lot of restraint for identifying when things aren't ready or when things have not been shaped enough. And so that's a trade-off and a practice that's needs more attention there, basically. So I have some thoughts here that, is there a way to achieve separate tracks if there isn't sufficient scale in a team? And I was basically relating this to the concept of daily 3S improvements, which comes from lean manufacturing. And in lean manufacturing, what that means is every day for the first 30 minutes or an hour of your day, you sweep, sort, and standardize. So basically you're making improvements to process, to your environment, to your tools at the start of each day. And so I was wondering, if you can't afford to have these 2 separate tracks, or if your organization isn't large enough for that, could framing and shaping work be done piece by piece, as kind of a daily practice, even while you're doing cycle work? So that's kind of a speculative thing that I'd like to prove out in the future with the team. And then I noted that confining all framing and shaping to cooldowns with a single track team is risky because there's pressure to define and bet on something before the next cycle starts. So again, if you only have 2 weeks to figure out what you're working on next, that may not be enough time. And it's really bad to bet on something that you haven't shaped enough. Or if you're not clear what the next business priority is, you probably shouldn't just commit, 6 weeks or really 2 months of time to building that if you're not really convinced about it. Lastly, I noted if teams can't do 2 tracks, then dynamic cycle start dates might be necessary. So what that would look like is a cycle ends and you spend as much time in cooldown as you need to until you found something compelling enough to place that bet. So that's another way you could probably approach it. But these are all kind of speculative implementations at this point. Steps to shaping. Shaping has 4 main steps that we'll cover in the next 4 chapters. Set boundaries. First, we'll figure out how much time the raw idea is worth and how to define the problem. This gives us the right boundaries to shape into. Rough out the elements. Then comes the creative work of sketching out a solution. We do this at a high level of abstraction. We do this at a higher level of abstraction than wireframes in order to move fast and explore a wide enough range of possibilities. The output of this step is an idea that solves the problem within the appetite, but without all the fine details worked out. Address risks and rabbit holes. Once we think we have a solution, We take a hard look at it to find holes in our unanswered questions that could trip up the team. We amend the solution, cut things out of it, or specify details at certain tricky spots to prevent the team from getting stuck or wasting time. Write the pitch. Once we think we've shaped it enough to potentially bet on, we package it with a formal write-up called a pitch. The pitch summarizes the problem, constraints, solution, rabbit holes, and limitations. The pitch goes to the betting table for consideration. If the project gets chosen, the pitch can be reused at kickoff to explain the project to the team. I just wanted to note that the pitch is now called a package by Ryan Singer. He kind of informally made ShapeUp 2.0 as a term, basically for things that he's learned applying ShapeUp to teams of other sizes. So I'll share a podcast episode where Ryan basically talks about the updates to ShapeUp after he moved on from Basecamp. But one of those key things is, instead of calling it a pitch, it's basically the work has been shaped up and packaged together neatly, and it's ready to bet on. So there's also less emphasis on betting activity in future versions of ShapeUp that Ryan has talked about. So that's why you're not really like pitching or trying to convince people to do it as much. So I'll refer to those things as a package as we go through. All right, next up. The first step of shaping is setting boundaries on what we're trying to do. The conversations we have are going to be entirely different if people think we're talking about a small improvement or a major redesign. The conversation about building a feature always starts with a raw idea, like customers are asking for group notifications. Before we all go down the rabbit hole discussing ways we can solve it, we should first set some broad terms on the discussion to make it productive. And I noted that jumping to a solution is one of the most common mistakes of any project, and we love to find solutions. Everyone's so excited to basically, immediately say, this is how we're going to solve it, but you really have to have the restraint to understand the problem deeply enough. And even before you really break down your understanding of the problem, make sure it's the most important problem to work on. Because if you specify ideas and you get really excited about them, you might commit yourself to work that it's not the best solution to the problem, or the problem's not even worth solving at all. Maybe not at this time or ever. Setting the appetite. Sometimes an idea gets us excited right away. In that case, we need to temper the excitement by checking whether this is really something we're able, it's basically touching on the point I was making, checking whether this is really something we're going to be able to invest our time in or not. If we don't stop to think about how valuable the idea is, we can all jump too quickly to either committing resources or having long discussions about potential solutions that go nowhere. Yeah, so basically reemphasize what I just said above, so my thinking has stayed the same on that. Other ideas are less exciting and feel more like a challenge we didn't ask for. The customer wants a calendar. We don't particularly want to build one, but we do feel we need to do something about the request. Whether we're chomping at, and this is actually a typo, whether we're champing at the bit, it should say, or reluctant to dive in, it helps us to explicitly define how much of our time and attention the subject deserves. Is this something worth a quick fix if we can manage? Is it a big idea worth an entire cycle? Would we redesign what we already have to accommodate it? Will we only consider it if we can implement it as a minor tweak? We call this the appetite. You can think of appetite as a time budget for a standard team size. We usually set the appetite in two sizes. So before we get into this, I have a lot of thoughts on these two sizes of appetites. Again, you're saying, how much is this project worth to us? How much would we be willing to spend on it? It has nothing to do with how long you think it'll take, because all estimates are inaccurate. There's really interesting studies by Vasco Duarte, I think, who has a website, or at least some talks, called No Estimates. And they found that at scale, if you studied large enterprise organizations and the accuracy of their estimates, they found that you would be better off just counting the number of tasks, because it's that arbitrarily bad. Humans are horrible at predicting how long something will take. So this whole Scrum practice of estimating and doing t-shirt sizes or Fibonacci sequence, they found that all of those methods, no matter how much you try to measure past velocity and capacity and all these things, they don't really allow you to predict anything, so you might as well just not do estimates at all. And that's very in line with ShapeUp. There's no estimation, just asking, how long should we work on this? So these two sizes, let's get into these. I have a lot of thoughts, so we'll kind of do a little side adventure on this. So the two sizes of appetites. Small batch. This is a project that a team of one designer and 1 or 2 programmers can build in 1 or 2 weeks. We batch these together into a 6-week cycle, and then we have big batch. This project takes the same size team a full 6 weeks. In my experience, and this is with ShapeUp with 4 different teams of various sizes, the small batch projects is where ShapeUp can go wrong for teams that are new to it, or if you don't have as much restraint around how you approach ShapeUp. So in my experience, small batch cycles have the same issues as any form of batch processing, which is waste due to increased context switching, communication and coordination overhead, and rework. And so to avoid this, it's critical that if you have multiple projects within one cycle, you have to set smaller appetites for each project and commit to that one piece flow. So let's say we have 2 projects in a cycle. One is going to take 1 week, and the other we think we're setting an appetite of 5 weeks on it. What you'd want to do is make sure that whichever one's more important, you do that one first, and you only do that one first. So we're going to spend the first week on this super important project, and we're committed to shipping it at the end of that first week. Then we know we have the remaining 5 weeks of the cycle. So we're going to work on the second project, and again, we're committed to shipping it at the end of that part of the cycle. So that's really critical to have that much structure around it if you're going to play with these small batch projects, basically. Without this, basically, you run into situations where you're working on multiple things at once, and it's really hard to know when you're going to ship them. It's hard to make trade-offs between them. And so I've just seen ShapeUp kind of fall apart a little bit with small batch projects unless you have those constraints on it. So another way of thinking about it is think of those small batch projects as unique scopes of a big batch project. So teams still must get one piece done at a time, end to end, or a whole vertical slice. So just another way of thinking about it. And I'm also making note here that when I've worked with startups that are more of an R&D phase, this is similar to how I've done ShapeUp with them, where cycle time is variable because we don't really know what we're building yet. We're doing a lot of R&D. Obviously, we're exploring kind of the territory, and we're not really sure what we're building right out the gate. So with this, sometimes cycles are as brief as a few days before we do a quick cool down and kind of figure out what we're doing next with framing and shaping. For an established company, it's probably better to have consistent cycle lengths of those 6-week cycles and make sure you just sequence those small batch projects within it and really stick to those fixed deadlines there. Yeah, let me see if I have other notes on this because I remember thinking quite a bit there. I think the only other thought I have on that is it's possible if you're really mature with ShapeUp and you're doing these small batch projects that you might be forced to make trade-offs between the 2 projects, and that might be intentional. That might be a nice constraint to have, but I think that would be hard to manage without basically feeling the downsides of batch processing. So I think the more you can stick to one piece flow, the better off there. All right, in rare cases where the scope is so big that a 6-week project isn't conceivable, we'll try to hammer it down by narrowing the problem definition. If we still can't shrink the scope, we'll break off a meaningful part of the project that we can shape to a 6-week appetite. I think that too should be another form of circuit breaker. If you can't think of any possible way to build something, a meaningful piece of an idea in 6 weeks, you probably haven't shaped it enough, and you probably don't really understand the problem enough to find an appropriate solution. So that'd be another kind of form of circuit breaker in my mind. All right, fixed time variable scope. Again, this is like, if you only take one thing away from ShapeUp, do this. An appetite is completely different from an estimate. Estimates start with a design and end with a number. Appetites start with a number and end with a design. We use the appetite as a creative constraint on the design process. This principle, called fixed time variable scope, is key to successfully defining and shipping projects. Take this book for an example. It's hard to ship a book when you can always add more, explain more, or improve what's already there. When you have a deadline, all of a sudden you have to make decisions. With 1 week left, I can choose between fixing typos or adding a new section to a chapter. That's the tension between time, quality, and scope. I think this is what my note is attached to here. Yeah, I have a couple here. So yeah, cool. So on this, we have fixed deadline, fixed scope, which is saying, here's the strict requirements we have to build, and I want it within 2 weeks. That results in variable quality, which is super damaging because the only thing you can do is basically just do it worse. So another permutation, fixed scope, fixed quality. This is kind of how I've experienced a lot of projects go. We know we have upfront requirements that we're committed to building, and we have a high quality bar. And what happens in projects like that is the deadline has to give, and that deadline slips and slips and slips, and you feel like you're never getting anything done, you're never shipping. So instead, if you have a fixed deadline, but you make the scope flexible, then that allows you to preserve quality because you're just doing less, but you're still doing it just as well as always. And so that's a really strengthening approach to this. And I'm also making note of that kind of value of constraints. So often by cutting scope, we end up with a better user experience than if we had time to build everything we could possibly think of. So we avoid creating waste and also long-term product and tech debt by only building what's essential. So that tension between, hey, we only have a couple of weeks left and I need to make sure it's as valuable as possible, that's a really good forcing function to preserve quality, and you might end up with something better because of the constraint. I don't want to release a book with embarrassing typos, so I'll choose to reduce the scope by leaving out the extra section. Without the pressure of the fixed deadline, I wouldn't make the trade-off. If the scope wasn't variable, I'd have to include the extra section. Then there'd be no time to fix the quality issues. We apply this principle at each stage of the process, from shaping potential projects to building and shipping them. First, the appetite constrains what kind of solution we design during the shaping process. Later, when we hand the work to a team, the fixed time box pushes them to make decisions about what is core to the project and what is peripheral or unnecessary. Yeah, that definitely hits hard, because if you make appetite an input to the building process, instead of doing upfront design or upfront requirements, then you're going to design a solution that's appropriate to how much time you want to spend on it. And that's how you hit the deadline, basically. If you've already decided scope and then ask how long it'll take, well, we're never going to be accurate. But if you flip that around and say, hey, we only want to spend this much time on a project, what can we get done? What do we think is realistic to get done? Then you're going to be much more successful at hitting that. All right, 1 second here. Good is relative. There's no absolute definition of the best solution. The best is relative to your constraints. Without a time limit, there's always a better version. The ultimate meal might be a 10-course dinner, but when you're hungry and in a hurry, a hot dog is perfect. The amount of time we set for our appetite is going to lead us to different solutions. We could model a whole set of database columns in the fancy version, or just provide a flat text area in the simple version. We could redesign the main landing page to accommodate a new feature, or we could push it back to a screen with fewer design constraints. We can only judge what is a good solution in the context of how much time we want to spend and how important it is. This is Ryan Singer is heavily influenced by Christopher Alexander, who's an architect that I mentioned earlier. And in my understanding of Christopher Alexander, you are basically matching the form to the context. So you can only judge the quality of something once you know the context in which it's going to be used. So you set that context up front with shaping, and then we can figure out what would actually be a good solution to that, given the time constraint and given our understanding of the problem, basically. Responding to raw ideas. Our default response to any idea that comes up should be interesting, maybe someday. Or in other words, a very soft no that leaves all of our options open. We don't put it in a backlog. We give it space so we can learn whether it's really important and what it might entail. And just to emphasize this again, there's no backlogs or roadmaps with ShapeUp at all. And this is to preserve optionality as one of the most valuable things. And most kind of permutations or mutations of Agile, I guess I would say, completely miss this, and they lock themselves into the opposite of agility, where every single decision is lockstep determined for months, if not a whole year in advance. So the real form of agility is after you ship each thing, you have a completely clean slate ahead of you. You have not made any commitments of what you're going to do next. That way you can respond and be agile to what you know presently right now, what you've just learned today, yesterday, the past, sprint, everything. You're responding to the current market, customer, and business needs, not what you thought last year when you put up a roadmap. So that's That's where preserving optionality is huge, and ShapeUp really helps with this. It's too early to say yes or no on first contact. Even if we're excited about it, we shouldn't make a commitment that we don't yet understand. We need to do work on the idea before it's shaped enough to bet resources on. If we always say yes to incoming requests, we'll end up with a giant pile of work that only grows. And that's my experience with backlogs. Some teams are really meticulous about backlog grooming, but a lot of times they just grow over time until you declare bankruptcy and delete your backlog and start over again. It's important to keep a cool manner and a bit of a poker face. We don't want to shut down an idea that we don't understand. New information might come in tomorrow that makes us see it differently. On the other hand, showing too much enthusiasm right away can set expectations that this thing is going to happen. We may not be able to commit to it once we've put it into context with everything else we want to do. All in on optionality, that's right. Narrow down the problem. In addition to setting the appetite, we usually need to narrow down our understanding of the problem. We once had a customer ask us for more complex permission rules. It could easily have taken us 6 weeks to build the change she wanted. Instead of taking the request at face value, we dug deeper. It turned out that someone had archived a file without knowing the file would disappear for everyone else using the system. Instead of creating a rule to prevent some people from archiving, we realized we could put a warning on the archive action itself that explained the impact. That's a one-day change instead of a 6-week project. So again, the goal of ShapeUp is not to do big projects. It's to only dedicate large amounts of time for things that are really worth it. Everything else, if you can get done on the spot, if you can fix what bugs you, if you can stop what you're doing and fix it right now, that's great. And that's also going to be something that we see is between cycles during the cooldown phase. That's a great opportunity to do these quick fixes, address simpler ideas and requests. But without shaping that, you might think you have to build a massive solution, and you might actually bet way too much time on it. Another example is the calendar view from the previous chapter. Everyone knows what a calendar view is, but unpacking it revealed tons of unknowns and decisions that would drastically affect the scope. If we only want to spend 6 weeks instead of 6 months building a huge calendar, how do we narrow it down? In that case, we flip from asking, what could we build, to what's really going wrong? Sure, a calendar sounds nice, but what is driving the request? At what point specifically does someone's current workflow break down without this thing they're asking for? Case study, defining calendar. In the case of the calendar request, we called a customer who asked for this feature. Instead of asking her why she wants a calendar and what it should look like, because you'll get a lot of things that lead down the wrong path with that, we asked her when she wanted a calendar. What was she doing when the thought occurred to ask for it? So I know for a fact that this is the jobs to be done, hiring and firing interview kind of approach. Ryan Singer is close with Bamo Esta and his partners at the Rewired group. So let me grab a link here, which I believe this is it. Hopefully that works. Let me double check. Yeah, cool. So this is a podcast episode from the Rewired group on the hiring and firing interview. And it's used to find the struggling moment when somebody experienced something. And this helps us basically figure out the demand side problem before we come up with our supply side solution. So instead of asking someone, what do you want to have in a calendar feature, we're really trying to figure out their actual struggling moment. So that way we can come up with a solution that addresses the problem instead of assuming it needs to be a calendar solution in this case. All right, so in this case, she told us she worked in an office with a big calendar drawn on a chalkboard wall. Her office mates marked when they were meeting clients in the handful of meeting rooms on the calendar. One day she was working from home. A client called and asked her to schedule a meeting. She had to drive to the office to look at the wall calendar. Traffic was terrible along the way, and in the end, there wasn't a free space that worked for her client. She could have saved an hour in traffic and a lot of frustration if she had been able to check for open spots on the calendar from her computer at home. The insight wasn't computerize the calendar, that's obvious. What we learned was that see free spaces was the most important thing for this use case, not do everything a calendar does. This story and others like it give us a specific baseline to design against. Basecamp had an had an agenda view of events. It worked for listing major deadlines and milestones, but it wasn't good for resource scheduling because you couldn't see empty spaces on it. We narrowed down the need from do everything a calendar does to help me see free spaces so I can figure out when to schedule something. We didn't have a solution yet, but now we felt like we had a problem that was specific enough to spark an idea that could fit within our appetite. This led us to the simpler dot grid concept from the last chapter. So now that they understood the context, they can now think of an appropriate form to fit that context. And so that's how you judge whether something's good. You can judge the fitness of it, in Christopher Alexander's words. Again, Ryan Singer takes a lot of inspiration from Christopher Alexander, so you'll see that it's embedded in the language here. What if we can't figure out a specific pain point or use case? Our appetite can also tell us how much research is worthwhile. If it's not critical now and we can't get our heads around the problem, we'll walk away from it and work on something else. Maybe in the future, a new request or story will pop up that gives us better insight into the problem. So I'm just making note that dedicated R&D projects were valuable in the earlier stage teams that I've worked with. So sometimes we bet an actual cycle on just looking into the problem space and understanding what the problems were, understanding which were worthwhile to actually build solutions for. And often the most valuable work with this was answering whether something was even possible before understanding how we would build it. So we would basically do spikes or prototypes to make sure that if we bet a future cycle on it, that this was even feasible, because with earlier stage teams and you're doing R&D, feasibility or whether something's even actually achievable is probably the biggest unknown. And then another note here is that that idea of walking away if it's not critical now and you can't really understand the problem deeply. That means that not betting on anything is one of the most valuable decisions, because it saves you 100% of the time and resources you would have spent. So again, the goal of ShapeUp is not to always do projects and always bet on projects. It's to make sure that whatever you work on makes it through this kind of gauntlet or through all this scrutiny to make sure it's the right time and the right problem to work on, and that you understand it deeply enough to actually commit time to it. Watch out for grab bags. When it comes to unclear ideas, the worst offenders are redesigns or refactorings that aren't driven by a single problem or use case. When someone proposes something like redesign the file section, that's a grab bag, not a project. It's going to be very hard to figure out what it means, where it stands, and where it ends. Here's a more productive starting point. We need to rethink the file section because sharing multiple files takes too many steps. Now we can start asking, what's not working? In what context are there too many steps? What parts of the existing design can stay the same and what part needs to change? A telltale sign of a grab bag is the 2.0 label. We made the mistake in the past of kicking off a Files 2.0 project without really considering what it meant. Our excitement about improving a huge part of our app got the better of us. We know there were a lot of problems with our Files feature, but we didn't ask ourselves what specifically we were going to do. The project turned out to be a mess because we didn't know what done looked like. We recovered by splitting the project into smaller projects like better file previews and custom folder colors. We set appetites and clear expectations on each project and shipped them successfully. Boundaries in place. When we have all three things, a raw idea, an appetite, and a narrow problem definition, we're ready to move on to the next step and define the elements of a solution. All right. Next up, find the elements. And just as a reminder, if anybody has questions as we go, feel free to pop them in the chat. We can definitely pause to go through those. Now that we have the constraints of an appetite and the problem we're solving, it's time to get from an idea in words to the elements of a software solution. There could be dozens of different ways to approach the solution for a problem, so it's important that we can move fast and cover a lot of ideas without getting dragged down. This is another reason why you don't want to work in high fidelity designs, because it's a whole lot of commitment. You feel really attached to the ideas, and it takes a lot of time. So what we'll find here is with a lot of these shaping techniques, they're very like throwaway, they're very quick, and they're very rough at first, and that's intentional so you can get through a lot of ideas quickly. Move at the right speed. Two things enable us to move at the right speed at this stage. First, we need to have the right people or nobody in the room. Either we're working alone or with a trusted partner who can keep pace with us. Someone we can speak with in shorthand, who has the same background knowledge, and who we can be frank with as we jump between ideas. Second, we need to avoid the wrong level of detail in the drawings and sketches. If we start with the wireframes or specific visual layouts, we'll get stuck on unnecessary details and we won't be able to explore as broadly as we need to. The challenge here is to be concrete enough to make progress on a specific solution without getting dragged down into fine details. The questions we're trying to answer are, where in the current system does the new thing fit? How do you get to it? What are the key components or interactions? Where does it take you? To stay on the right level of detail and capture our thoughts as they come, we work by hand using a couple of prototyping techniques, breadboarding and fat marker sketches. These allow us to quickly draw different versions of entire flows so we can debate the pros and cons of each approach and stay aligned with what we're talking about as we go. Breadboarding. And I have an example of this I'll show in just a second here. We borrow a concept from electrical engineering to help us design at the right level of abstraction. A breadboard is an electrical engineering prototype that has all the components and wiring of a real device, but no industrial design. I'm going to pop open the original here, so light theme warning here. Let's find the image of that. Okay, yeah. I'll pull this back up in a second here for these affordances. And I also have a Figma example that I can show you here. Deciding to include an indicator light and rotary knob is very different from debating the chassis metal, or whether the knob should go on the left of the light or to the right, how sharp the corner should be, and so on. Similarly, we can sketch and discuss key components and connections of an interface idea without specifying a particular visual design. To do that, we can use a simple shorthand. There are three basic things we'll draw. Places. These are the things you can navigate to, like screens, dialogues, or menus that pop up. Affordances. These are things the user can act on, like buttons and fields. We consider interface copy to be an affordance too. Reading it is an act that gives the user information about subsequent actions. Connection lines. These will show how the affordances take the user from place to place. We use words for everything instead of pictures. The important things are the components we're identifying and their connections. They allow us to play out an idea and judge if the sequence of actions serves the use case that we're trying to solve. All right, so there's an example here that we'll go into, and also let me pull up this Figma example here. And this is something I've used on actual work before. Let me see, I should be able to pull this up hopefully. Yeah, so this is just an example of a very simple Figma template. So places are underlined, affordances are listed underneath pages or places, and then you basically create connectors from affordance to affordance. So if you had a link on the home page that takes you to a pricing page, then we'd have a home card, and then we'd have a pricing card, and the affordance of that link is what takes you over there. This works for form fields and everything else that's interactive, basically. So I've used this level of abstraction to map out clients' entire web apps or websites before and kind of capture how they're working now. And it really quickly reveals all the complexities of it and areas where you can vastly simplify the design. And then so you would redesign it by basically, creating a new breadboard that shows the critical flows and connections there. So this is a much lighter way of working than like capturing screenshots and, putting everything into a prototype or taking a huge inventory. So it's a really nice level of abstraction basically. And then the paper version of this is very similar. So, pen and paper, you would make a place with an underline. You would list the affordances underneath, and then you just draw connecting arrows between them to show how each affordance gets you to a destination. So this is very good for auditing existing UI or basically designing new flows. So very lightweight approach there. All right, example. Suppose our product is an invoicing tool. We're considering adding a new autopay feature to enable our customers to pay future invoices automatically. How do you turn autopay on? What's involved? We can pick a starting point and say that the customer landed on an invoice. That's our first place. We draw it by writing the name of the place and underlining it. Again, I'm not sure why the images aren't showing up here, so I don't want to have to flip back and forth too much. Let's just continue on as a reference with the light theme version. Here's basically the level of detail that we're working with in this example. So on the invoice, we're thinking we could add a new button to turn on autopay. That's an affordance. Affordances go below the line to indicate they can be found at that place. Where does that button go? some place for setting up the autopay. We don't have to specify whether it's a separate screen or pop-up modal or what. From a what's connected to what standpoint, the topology, it's all the same. So this gets you out of thinking about things in terms of UI or the finished details. It's just thinking about the connections, just thinking about the interactions and what functionality needs to be in place. And a lot of times you can even achieve your content writing with this level of specificity without even really knowing the design yet. And that allows you to have the design be more emergent from the flow instead of fitting your content into a high fidelity mock that didn't consider the language up front. Now we can talk about what belongs on that screen. Do we ask for a credit card here? Is there a card on file already? What about ACH or other payment methods? Just figuring out what to write under the bar starts to provoke debates and discussions about what to build. As we think it through, we decide we should ask for credit card details here and show the logo of the financial institution, an aspect of the domain in this specific product. Straightforward enough, but wait, did we actually pay the original invoice or not? Now we have both functional and interface questions. What does enabling autopay do? Does it apply only for the future, or does paying with autopay for the first time also pay the current invoice? And where do we explain this behavior? We're starting to have deeper questions and discussions prompted by just a few words and arrows in the breadboard. Since we're using such a lightweight notation and we aren't bogged down with wireframes, we can quickly jump around and entertain different possibilities. So again, going back to the original, maybe I'll just read off this for a minute here since those images aren't there. You can really quickly work with permutations of this level of design without really committing much there. So I think I'm going to kind of skip ahead on these because this is a very specific example, but you can see that that iteration is so cheap to do at this level of abstraction, which is what we're after. So let's move on to fat marker sketches here. And just seeing if anything else I had notes on here. One other note from that breadboarding section, reflecting strategically on what they knew about their customers, they thought it would be quite all right if the invoicer's customer had to reach out to the invoicer and ask them to turn off autopay. So this is basically a form of scope hammering in which you're determining whether you even have to build this feature or not, or if you have to build it if there's a really simple solution to it. And so you're already really thinking about the scope early on, instead of just taking a requirement as something that you have to preserve in all cases and betting on a fixed scope. So the trade-offs of complexity versus value are easier to assess without any investment in building the solution. So this is preventing all that waste from occurring up front. The like lower fidelity solution and the cheaper kind of throwaway temporary artifact approach to design, that's going to reduce the waste vastly with this approach. I'm going to continue on through some of these notes. So writing out the flows confronts us with questions that we didn't originally think of and stimulates design ideas without distracting us with unimportant visual choices. So again, not getting bogged down in the visual details. Once we get to a place where we play through the use case and the flow seems like a fit, we've got the elements we need to move on and start defining the project more clearly. We're getting more concrete while still leaving out a huge amount of detail. All right, fat marker sketches. Sometimes the idea we have in mind is a visual one. Breadboarding would just miss the point because the 2D arrangement of elements is the fundamental problem. In that case, we still don't want to waste time on wireframes or unnecessary fidelity. Instead, we use fat marker sketches. A fat marker sketch is a sketch made with such broad strokes that adding detail is difficult or impossible. We originally did this with large tipped Sharpie markers on paper. Today, we also do it on iPads with the pen size set to a large diameter. So if you recall that earlier visual example of the calendar dot grid, where it was just like a really rough sketch, that's basically what this is here. Here's an example. We found ourselves often creating fake to-dos and Basecamp to-do lists that acted as dividers. We'd create an item like hyphen, hyphen, hyphen needs testing and put items below it. We had the idea to make some kind of an official divider feature in our to-do tool to turn the workaround into a first-class function of to-do lists. We had to work out what the implications of adding a divider were. We came up with the rough idea that adding a divider separates the list into loose to-dos above the divider and grouped to-dos below. Adding subsequent dividers adds more groups below the loose items at the top. All right, I have to toggle over one more time. So with the fat marker sketches, again, it's that level of fidelity where, even labeling things with words is pretty optional, but you're not going into too much detail here because you're trying to avoid the design decision part of it that is stuck in the design tool and just get down to the actual functionality and features of it. So just continue on here. We were a little concerned the add buttons might break up the gestalt of the list, and the groups might all separate too much from the lists on the page. So gestalt is basically like the form of it. We talked about possibilities to place the add affordance inside of a menu that we already had to the left of each to-do item. This notation is much less constraining than breadboards, which has downsides. We might sketch a sidebar and get it attached to a layout element like that, even though it's not a core element. But as long as we keep an eye on that, we're still far better off than if we get sucked into the weeds by creating wireframes too early. It may seem a little silly to call fat marker sketches a technique or tool. The reason for calling them out is we too easily skip ahead to the wrong level of fidelity. Giving this rough early stage a name and using a specific tool for it helps us segment our own creative process and make sure we aren't jumping ahead to detail a specific idea when we haven't surveyed the field enough. All right, I think we're out of the weeds with the images, so we can go back to dark mode here. Elements are the output. In the case of the autopay out example, we ended up with some clear elements. A new use this to autopay checkbox on the existing pay and invoice screen. A disable autopay option on the invoicer side. For the to-do groups project, the elements were loose to-dos above the first group belong directly to the parent. Group to-dos appear below the loose to-dos. We'd like to try and add affordance within each section, but if that doesn't work visually, we're okay with relying on the action menu for inserting to-dos into position. Similarly, when we sketch the simplified solution for rendering events on a calendar grid, we use the fat marker approach. So these elements here are really interesting because they basically, this is the kind of full definition of the solution in a lot of cases. If with this language here and a couple sketches, that's enough detail to hand off to somebody to build, and the expert who's building it, both from a design and programming perspective, can add whatever level of detail and whatever level of polish they need, but they know what it has to achieve, what it has to lead to. So we've locked in the requirements without constraining the solution too much. This enabled us to work out the main elements of the solution. So back on that dot grid example, a 2-up monthly calendar grid, dots for events, no spanned pills, agenda style list of events below that scrolls an event into view when you tap a dot. This list of elements is extremely narrow and specific compared to monthly calendar, exactly the kind of narrowing we hope to accomplish through the shaping process. So even like the verbal description can be very specific, and the design is not prescriptive at all. There's no like lockdown high fidelity mocks, but we still are going to make sure that we achieve the specific functionality that we're looking for. Room for designers. Later, when it's time to involve a designer, you don't want to have to say, I knew I drew it like this, but ignore that. Regardless of what you say, any specific mockups are going to bias what other people do after you, especially if you're in a higher position than them. They'll take every detail in the initial mockups as direction, even though you didn't intend it. Working at the right level of abstraction not only ensures that we move at the right speed, it also leaves this important room for creativity in the later stages. By leaving details out, the breadboard and fat marker sketches give room to designers in subsequent phases of the project. This is a theme of the shaping process. We're making the project more specific and more concrete, but still leaving lots of space for decisions and choices to be made later. This isn't a spec. It's more like the boundaries and rules of a game. It could go in countless different ways once it's time to play. Not deliverable yet. This step of shaping is still very much in our private sphere. It's normal for the artifacts at this point, on the wall or in your notebook, to be more or less indecipherable to anyone who wasn't there with you. We've gone from a cloudy idea like autopay or to-do groups to a specific approach and a handful of concrete elements. But the form we have is still very rough and mostly in outline. What we've done is landed on an approach for how to solve the problem, but there may be some significant unknowns or things we need to address before we'd consider this safe to hand off to a team to build successfully. The next step is to do some stress testing and de-risking. We want to check for holes and challenges that could hinder the project from shipping within the fixed time appetite that we have in mind for it. After that, we'll see how to wrap up the shaped concept into a write-up for pitching. No conveyor belt. Also keep in mind that at this stage we could walk away from the project. We haven't bet on it. We haven't made any commitments or promises about it. what we've done is added value to the raw idea by making it more actionable. We've gotten closer to a good option that we can later lobby for when it's time to allocate resources. Yeah, so just ending on this note, I think this will probably close out this stream as well. Again, at any step of the shaping process, whether it's a raw idea or you've completely packaged it up and you've figured out all the solutions and you sketched everything out, you still have to bet on it. So if it doesn't seem like the right time to do it, or you're still not really sure that you want to take on this project, the best decision is just not to do it at all, and then go back and figure out what is the next project we'd like to bet on. So with all these practices in place, should hopefully reduce a lot of the overhead of the product development process. And in the next session, we'll probably live stream again next week. We're going to get into rabbit holes and taking the risk out of potential projects, what it looks like to package those up, and probably get into what you actually do during the cycle work when you kick off the project and you start building things. So yeah, that's it. If you have any questions, feel free to leave them as comments and I'll get to those. And then I'll probably kick off another stream similar to